Yeah, please go ahead. Share your screen and explain important concepts, whatever you feel. You start. I also ask my own points.
Okay.
Shall we start from the digital? Do you have digital material?
Mm.
Open with.
Where is that?
Uh,
It is has open with return it. Okay, okay, wait. I don't know what. Let's start. Okay, can you explain the modeling difference between gate level, data level, and behavior level?
yeah, sure. In gate level, we will design in a structural model. This is also called as a structural modeling, where we will design in a gate level. For example, if I take AND gate and output, we will mention in the port list, sensitivity list, output first, after that inputs A, B. But the same thing we can do it in data flow model. In data flow model, what will happen means we will assign y equal to a and b. In behavioral model, we will do with the level of constructs like always block, always com logic, always latch, always ff, always address passage for sequential logic, like that. That is behavioral level. That is the highest level where we will model all our duties.
Uh, I mean to say, in the gate level, in the tool, what level you write? You write at gate level or data flow level or behavior level?
It depends. We can write in three, any one of the level.
It depends, but let's say I have given you a processor coding. In which level you want to write?
Processor means ALU logic. I'll write it in behavioral model.
Mm-hmm.
Remaining memories, all these things, L1 cache, L2 cache, L3 cache, those are in a data flow model. Gate level, wherever there is a circuit is required, there I'll write.
Okay.
Mostly I will write in behavioral model only. That is the simplest way of user friendly.
Yeah.
In three ways, it displays the same output. It will give the same output. So the easiest way is behavioral model. So I'll opt for a behavioral model.
What does tool understand?
Tool understand gate level only. Netlist.
Okay. So we have to. The main difference between is if you have 20 lines of code in behavior, it will be multiplied some 10 times, right?
Yeah.
So 200 lines will be in the gate level.
Okay.
So it is very painful in writing in gate level because you have to write every gate and code it.
Yeah.
Even you want to do the structural modeling also, you have to code some in number of gates and you have to repeat it.
Okay.
So that's what
Is
structural
there any
data
difference
from.
between structural and gate level? Both are same, I feel like, right? Isn't it?
Yeah, it's same, but in gate level, what you do is you write n number of gates,
Okay.
and that's what gate level is.
Okay.
So in what mean of structural is you repeat that n number some m times.
Okay.
You use that block some n number of
With
time,
the help
m
of
number.
instantiation, right?
Yeah, instantiation of some gate level code is called a structural level code.
Okay.
In data flow level, we you use the keyword called assign, and
Assign.
it is used for you, how the data flows. Like you can't use the gate, you can use the symbols here.
Yeah.
Yeah, and if I will come to the behavior model, in general, we model the sequential circuits. Why? Because always that it means that it clock generation is required.
Okay.
We use that between. So, can you explain about the task and function?
See, task and function are two methods, whether we can write it in a class or a module or in a program. So, function will take zero simulation times to execution. Task will consume a time if required, and wherever time constraints are there, we will write it in task, and wherever there is a zero simulation time constraints, those we will write it in a function. And if there is purposefully, if we want to invoke a time in a function, then we need to make use of the sorry, I'm not able to recollect right now. Wait a minute. Fork join. If we write fork join block, then it can consume time also in a function as well. There is a ready to end phase is there in a UVM that consumes the time. That is though that is a function. So through that I understood like uh, even in a function also we can induce a time.
Can you write a piece of code explaining how you write the function, how you introduce a delay in functions?
Yeah.
Like in by default, people won't use delays in functions.
Yeah. Yeah.
So it's very rare, right?
Yeah. Yeah.
So is it's a industry applicable to use delays in function?
No, it is not applicable, but still if it insists at the time we can write. There is one ready to end phase. One of the user defined phase is there in UVM, that is written in a function. In that function we will induce some time. For example, like can I
Can
share
you
my
write
screen
code,
and write?
like very minimal code to explain that?
Yeah, sure. Function ready to end phase, UVM phase uh, super dot ready to end phase. Within that I'll write a fork join block. In that fork join block, hash 10 semicolon, begin end hash 10 semicolon, I'll write. So it will take 10 simulation units. If it is 1 nanosecond by tick, the time scale directive is 1 nanosecond by 1 picosecond, then it will take 10 nanoseconds. That is there. I have an example, I'll show you if you need. That is only the special case that till now I encountered with where function can consume a time. Remaining all cases, function will execute in zero simulation time.
Okay.
In four delta cycles, it will execute. I think the zero simulation time only it will go like four delta cycles: delta cycle zero, delta cycle one, delta cycle two, delta cycle three. They where event simulation, event Q will come into the picture. Event Q will dealt from one. From one timestamps to another timestamps. In between, what will happen through event queue, it will happen either in Verilog or system Verilog.
Okay.
That will be removed in that was removed in UVM. There we have fixed phases the simulation flow will go rather
Well,
than
well.
event.
Okay, Dhanush. I want to give some questions like, see, can you write a piece of Verila code for for up and down counter? It has to start with zero, and it has to come to the 15, and again it has to go from 15 to zero.
Okay, okay, I'll take count value 3 down to 0. I'll increment my counter. I have a if block. Whenever I'll reach a if block equal to f of 4 tick hf, then it has to decrement
Can you
count
write it?
minus 1.
Can you write it?
Write the code. Okay, okay, I'm sharing my screen.
Okay.
Module tv in module. I'll take some intermediate value known as count, or else initial value. I need to make it better to take it as bit bit
Okay.
3 down to 0 count. Always intermediate offset clock put clock RC always erase of such clock. RSTN RSTN
Push, bro, for 2 minutes.
okay,
You
okay,
write the. I will come.
okay, okay, sure, sure. Achyut? Achyut, are you there?
Hello.
Yeah,
You wrote the code?
yeah, I wrote some simple code.
Yeah.
Any mistake is there?
Here, we should not declare like this reg in CN itself.
CN, okay.
Like you have to declare a CN above Qatar gas. Like before, after bit, you have to give reg CN.
Okay.
Okay.
Okay. Is it fine now?
And second thing is when you on the reset, then CNT will be 0 and again it will go to plus 1, right?
Huh? Yeah.
So you should not keep reset in logic like plus 1 or minus 1. Plus 1, I think.
Okay.
Why? Because every cycle it will be 0 again plus 1, 0 plus 1, 0 plus 1 like that only, right?
Yeah, yeah, yeah.
Then
Where I need to keep this one?
you should that below plus 1 logic should not be there.
This one, na? then how it will increment the count?
you, you should take it you should take it up. You should take it again two variables, up and down. If up equals to 1, you have to give cnt equals to cnt plus 1.
Okay,
If down equals to 1, you have to take cnt equals to 15 and you have to do decrement.
okay, okay,
And you should not include a logic at reset. Reset is used for only for initialization to get into the default values. You should not give the logic to that. Okay.
okay, okay.
Do you know ripple carry counter?
Yeah,
Can you tell about that?
ripple carry counter. That is ripple carry counter.
Ripple carry adder.
Yeah, yeah, that's what ripple carry adder. Ripple carry adder means the carry will ripple from first full adder to the last full adder. So carry out till carry out it will come. Adder all the inputs A's and B's will be on this simultaneously. It will execute at the zero simulation time, evaluate at the RHS side, and the carry will be propagation. Two values will be there. One is propagating and another one is uh, one more I am unable to recollect. So it will calculate those values and assign to the uh, next full adder through combinational logic.
Can you
XOR
write
is
some? Can you write sum and carry data flow assignment?
for 4 bit.
Yes, for any bits like for you write for 3 bits.
3 bits. Sum is XOR operation. Carry is AND/OR operation.
Write two lines for that data assignment. Only 2 lines I need.
Yes, yes. GM sum equal. CM. Sorry, I'm unable to recollect cout expression right now. I need to go through very long digital things. I'm going through only UVM currently. That is
Okay.
AND/OR operation. A and B are B and C are C and A. Likewise, can I write that
Okay.
expression? Is it right or
That is right, but you know and right in data flow and
yeah,
then you know or right for data flow.
yeah, yeah.
Then
And B. Yeah. Hello, Achit, are you there?
Yeah, I'm there. Ca- Can you know when you have to use double and when you have to use single?
Double means logical and
Uh,
single means reduction and reduction and.
so we are doing logical or reduction.
We are doing reduction.
Okay. I think
With
you
XR
should.
also one expression you will get. I seen XR AX seen R AXR AXR B also some expression is there. That is a derived expression that I am unable to recollect currently.
Okay, okay. Uh, can you?
Are these expressions are correct or should I need to go through once?
Doshako. Yeah, these are correct. Can you tell what is T flip flop? T.
T flip flop is a toggle flip flop. If you give one, it will toggle. If you give zero, it will remain its old value. It retains its old value.
Okay. Uh, well, you in the above code, you do one thing
Okay.
like you do. You have given synchronous negative reset, right?
Yeah.
Now I want asynchronous negative reset.
Okay. Here I need to put R ARSTN. I need to put.
Do that.
ARSTN.
So it is asynchronous negative reset.
Yeah.
Okay. Okay. In general, in industry, what it is preferred like synchronous and asynchronous.
Asynchronous reset and they will prefer.
Okay. Then you know why?
As I know, whenever asynchronous means whenever this is ARSTN high at that time we are initializing that that takes very little amount of time. So in that we all initialize the values and wherever there is ARSTN goes to low at that time my device operation will take more time compared to initialization. So we can save the power. That's what I'm thinking. If we invert this, then more power we need to give for operation for resetting.
Okay. Okay, Dhanush. I need you have done AXI, right?
Yeah, yeah, exactly. Yeah.
So here I have the memory RAM, okay,
Okay.
and I have the CPU.
Okay.
So here I want to communicate between CPU and memory.
Okay.
Can you say, is it possible to do with AXI or APB or any other protocols?
those are amba buses. So that is also one of the bus. It is none other than it's a passive bus. It doesn't have any intelligence. So you can use anything. It depends upon the clock frequency we will use. For better performance, if it is a high speed processor, like 100 megahertz, then better to go for this AXI. If it is 50 megahertz moderate, then better to go for AHB. If it is low, if it is a little bit less, 25 megahertz, then better to go for APP. Whatever you will go, all these are all buses only. So those will have a read write transaction with respect to memory from the CPU.
How many channels is present in AXI?
AXI have 5 channels: three write channels, write access channels, two read access channels.
In right axis or read axis?
Okay.
In read axis, can you say response channel present?
Yeah, response channel is embedded in data channel itself.
You wrote the code of AXI in UVM.
Yeah, I wrote.
Okay. Like, can you draw the architecture of it?
AXI.
Yeah, in UVM. I need only architecture.
Okay, sure.
I need only component boxes and names in a single minimum words. I have to see more blocks. Have done the IP or VIP?
I have done VIP, and I integrated in slave as a DUT.
Okay.
Here, here I have a top test
Mhm.
environment. This is active agent. This is passive agent. In this
Mhm.
three components are there. Here only monitor is this sequencer driver monitor is present in active. I am sampling it in environment. I have a scoreboard. I'll compare it. Scoreboard checker.
Okay. You for that passive agent, you removed it and you put it as a hello.
Yeah, yeah. Tell me, I'm listening. What should I put it, Ajit?
You told that you put it as a DUT, right?
Yeah, yeah.
So what component you connected?
To DUT.
What is DUT? Like what component connected?
Through interface, we will connect to DUT. DUT is a module static component.
Okay, you have worked right. You have more experience in the DUT. What it is? What component it is?
Sorry, I'm not getting your question. What component it is means what?
Like whether it is a PCI or whether it is a
No, no, no. AX is slave DUT.
AXI slave DUT. You removed it. Like you have to say like it's a slave, right? You have communicating from CPU to the one of the
Slave.
things.
Yes.
So what is that
Like a
slave?
memory chunk.
Okay, you are communicating with the memory.
Yeah.
So what about the CPU?
CPU is act like my master.
Okay, master here is AXI master, right?
Yes, AXI master controller.
Okay, in I mean to say there is a CPU. How you connected the CPU with the AXI master controller? What signal needs to be connected?
Control signal plus address and data, I'm thinking. Whenever that it will take that control, at the time control signals should be there along with the address and data to write it into this slave memory.
Speak the signals from the CPU. You took certain signal out, and those certain signals have connected to the these things. AXI master. What are those signals?
Valid signal I need to take out from the, sorry, CPU has ALU has 9 operations additions. Sorry, I don't have knowledge on that, Ajit. Can you please explain that?
Well, there are. It depends on what you want to do. The clock and reset comes out of the CPU,
Okay, global signals.
global signals, and
Okay,
the second thing is the all are the internal signals, right? So you have to evaluate all the signals what AXI has. So whether it has given an address, who is giving at the address? CPU, AW address.
yes.
So I want to write a data from the CPU to the memory.
Okay,
So how can I write? What should I need to write there?
both
I
address and
need,
data on control signals are required. Clock and
that's
reset,
I
as well
require
as
clock.
valid signal also required. Based on if valid is high, then only it will write the data. Otherwise, it won't.
These things you have to tell. So I want to write it in the
But
memory.
CPU has that ALU block, right?
Yeah,
That ALU block output is only 9 operations, right? Addition, subtraction, multiplication, division, logical operations, and shift operations, arithmetic shift and logical shift. So where are those signals are coming? That's what I got doubt and I got stuck.
here you have to give the there is an instruction memory
Hmm.
in the CPU.
Okay.
In that instruction memory only we will give the particular address
Hmm.
and particular data
Okay.
what we have to given to the memory. that
Okay. If
that
if I want
instruction
to
machine
do
code
write
we have to
operation,
give. That
the
9 operation is the it's a internal data like uh, let's say in the instruction memory you want to add 5 and 6.
okay.
uh, you want to add 5 and 6 and give it to the memory, right?
Hmm.
So that internal operation adding is done by the ALU.
Okay. Okay.
You want to do some other multiply you want to do,
Okay.
so that multiply uh, will go give has happened. ALU does these kind of things like it's a arithmetic things it can do and logical things it can do,
Hmm.
not not memory. You have to these instructions we have to give in the instruction memory. The instruction memory address and the data has to be given to the instruction memory, and that instruction memory uh, comes it as the memory address. There will be a three memories there. One is a instruction memory,
Okay.
another is data memory, right?
Yeah. Yeah.
So in this way you have to do when you So when you do the IP, you will understand it better.
Okay.
Well, well. What about your you done PCI, right?
Yeah, PCI.
Can you explain what is the use of tag?
What is the use of
Tag.
tag? Sorry, I worked on only. I didn't work on TLP layer. I used to know, but I forgot that. Please explain.
Like header, right?
Yeah, header format. Yeah,
In
the
header
header
only.
tag will be there.
Okay.
Frame type. After that, frame is 3 bits. Frame type is 5 bits.
No, I am asking about tag.
Sorry, I'm unable to recollect right now.
Okay, okay. When there is let's say you want to do memory write
Okay.
in that. So what you should do? What from the CPU to the endpoint?
Hmm.
There is a structures, right? There is a root complex and there is a switch and there is a endpoint. It's a fabric. So you actually want to do the memory write. You want to send the data from memory to the endpoint.
Hmm.
So that endpoint may be a GPU or anything.
Hmm.
So
GPU or high speed SSD NVMe.
yeah. So you want to do any kind of memory read. Its memory read is a posted or non-posted.
Uh, that is non-posted.
Okay, non-posted means
No acknowledgement will require.
sorry, posted means no acknowledgement required.
Posted, no non-posted, non means ENM. Yeah, 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 yeah. Okay. Acknowledgement will required. I'm getting confused with that.
Think it like this. Let's say you go to the post office.
Okay.
You post it, right?
Yeah.
So there any acknowledgement comes there from their end? No.
No.
They won't, post office won't call you and say, right?
Yeah, yeah.
So in like that you can remember. Here I want to say that when you want to do memory read,
Okay.
so from the endpoint to CPU. So what you do? You need a completion TLP, right?
Yeah.
Completion package it's required.
Yeah.
So that completion packet for that generation and the requester packet it will be there, right?
Yeah.
So that completion packet and the requester packet should match.
Okay.
So that matching how it happens? If the tag is same,
Okay.
it won't see anything.
Okay.
It will say those requested packet and completer packet is matched.
Okay.
So in memory read or IO write read, configuration write read, these things happens.
Okay.
So it will accept the completion TLP and the requested TLP. It's already there, and the tag from the requester and the completer TLP should be matched. That's what the tag is.
Okay. Okay.
Can you say what is your requester ID? Can you know about it?
Yeah. Requested ID. It will initiate from TL. It will initiate from RC to the EP, stating that it need to get the BDF bus device function. Bus will be like 5 bit. Bus will be like 8 bit. Device will be like 5 bit, and function will be 3 bit total. These three altogether total will be 16 Mbps. So bus will be 8 bits, so 256 buses. Which bus it need to connect to the link up In L0 link up, which bus it need to be connect?
Here, you are saying that you are using the bits and all, but the higher people will know the concept only, or not like you should explain in a way that you should not say this bits and these bits because they don't know.
Okay.
I think they know only the flow, basic flow. Like requester ID is used for endpoint, right?
Yeah.
So for particular endpoint, there will be a one requester ID.
Hmm.
Let's say there is a GPU.
Okay.
There is one requester ID.
Okay.
Let's say there is a network card. One requester ID is there. Okay.
Okay.
So you randomize the requester ID
Yeah.
in sequence, or you have to give inline constraint like only this, uh, only for GPU you have to give, or you
That is
randomize.
16-bit, right? So I'll randomize it.
Okay. So the tag, and what about tag? You randomize or you will give an inline constraint?
Tag it is for particular operation, so I'll give it an inline constraint.
Let's say for one transaction it will be go like that, right? For another transaction there will be a new tag.
Okay.
For another transaction there will be another new tag.
Okay.
So the tag will be different, right? For every nanosecond, so that it will match, right? From completer to requester it should match. So every time it should be new.
Okay.
So you randomize or you put it in inline constant.
I'll randomize it.
Okay, right. You know, in PCIe, we will connect to CPU. It the PCIe actually what you do, it's inside the chip or outside the chip.
PC is like a board, NIC board. It kind of a board. It is outside of the CPU.
Yes. So from the CPU pins, it is connected to the board,
Yeah.
and that board end is connected to the GPU.
Yeah.
Okay. Okay, Tanush. Let's discuss afterwards. Your basics is you are telling good.
Okay.
So let's I mean to say is whenever a question asked, my feedback only is whenever the question asked, you restrict to that question only,
Okay.
and your most of the answers are for me it's nice. Like you are explaining in a shorter way what is required.
Okay.
Okay, that's what my feedback is. Thank you.
Thank
We
you.
will meet afterwards.